Alright, let's understand one of the most basic and fundamental concepts of Node.js and computer science in general: buffers. Now, to really be able to understand buffers, we first need to get a good grasp on 4 simple computer science topics: binary data, binary numbers, and hexadecimal numbers or base 16 numbers, and character sets and character encodings. So let's start to understand these 4 topics one by one. Okay, let's start with binary data. What is a binary data? Well, it's a data that its unit only has 2 possible states. Now, we tend to call them zeros and ones. And basically, everything you have on your computer, everything you see on your computer is just a binary data. For example, an image is just a binary data. At its core, it's just zeros and ones. An application, a sound system, all of it is just zeros and ones. And we have different ways to represent these zeros and ones. For example, a CPU uses transistors. Now, Apple M1 has roughly around 16 billion transistors. And each one of those transistors could either represent off or on switch. Now, they use electricity to do that. For example, if a transistor has power in it, it means on, or if it doesn't have power in it, it means off. But it's roughly the same concept, either on or off, either 1 or 0. Or Wi-Fi and 5G connections, they are all connecting using zeros and ones. In their cases, they use waves, and if you're familiar with them in physics, you would have some idea about how they work. For example, each bump could represent a 1. And the same goes with storage devices like flash drives, CD drives, and hard drives, SSD drives. They all have their own system to store zeros and ones. The point is, it's just zeros and ones and nothing else. So if you face a problem in computers and you're scratching your head around wondering what is really going on, well, take a deep breath and tell yourself that it's just zeros and ones. Alright, so let's have these little boxes on the screen, and this is our own way to represent either 0 or 1. It could be a transistor, it could be anything. But in this case, we took these boxes. And each box is 1 bit, and 8 bits is equal to 1 byte. And each one of these boxes, each one of these bits, could either have 1 in them or 0 in them, and that's all. Either 1 or 0. Now let's put some data in these boxes and see what that would mean. So I'm going to put these things on them. So let's say we have 0, 0, 0, 0, 1, 0, 1, 1. Let's see what exactly this means. So, well, it's a number. It's called a binary number. Now, what is a binary number? Well, it's a numeric system that we only use 2 characters to represent a number, either 0 or 1. It's also called base 2 numbers, and we're going to see in just a minute why. So, to understand what this binary number means in our own numeric system, we have to do a little bit of math. We have to take each character and multiply it by 2 to the power of its index. For example, we take 1 and we multiply it by 2 to the power of 0. 0 is its index, and then its result, which is 1. Then we take the second character, multiply it by 2 to the power of 1, which equals to 2. The third character, which is 0, the fourth character, and the last one. And then we multiply them all by 2 to the power of their indexes, and then the results. And finally, we take all these numbers and we add them all together, and then the result is the number that this binary number represents. It's really that simple. So using that binary format that we just talked about, right now we could represent different numbers. Pretty cool, huh? Now, in our previous slide, we had the same number, but it had a bunch of zeros before it. But it doesn't really matter, because all of those zeros would be multiplied by 2 to the power of something, and 0 times anything is 0, right? So we could really drop all of these zeros before the first one that appears. Just like that. So this is binary number, which is also called base 2 numbers, because we take each character and we multiply it by 2 to the power of something. That's why it's called base 2. The number system that we use is called base 10 numbers, and the way we calculate it is similar to the binary number, but the difference is we multiply the characters by 10 to the power of their indexes. We take 9 times 10 to the power of 0 is 9, 1 times 10 to the power of 1, which is 10, and then 3 times 10 to the power of 2, which is 300. And then we add them all together, which is 319, the exact same number. And this is called base 10 numbers. It's a number system that we all use, right? Now, similarly to these two, we have another numeric system called base 16 numbers, or so-called hexadecimal numbers. The way these work is just like before. We take each character and we multiply it by 16 to the power of its index. And just to distinguish between base 16 numbers and base 10 numbers, we add something before these numbers, usually 0x or something else, hyphen, a sharp sign, pretty much anything. We just want to say that, hey, this number that you see is not a regular number and it's a base 16 number. So this little 0 and x or any other thing that you might probably see is just an indicator and nothing else. And the way we calculate this number to find out what this hexadecimal number expresses is just like those methods that we just saw before. We take each character, so 6, we multiply it by 16 to the power of its index. In this case, it's 0, so we multiply it by 16 to the power of 0, and the result is 6. We take 5 times 16 to the power of 1, which is 80. And then 4 times 16 to the power of 2, which is 1024. And then, just like before, we take them all and we add them together. The result is 1110. So this hexadecimal number, 456, is this number. That's really how simple hexadecimal numbers are and binary numbers are. Now let's take a moment and talk a little bit more about hexadecimal numbers, because they could be a little bit more complicated than binary numbers. But not complicated, but they have more characters available to them. In this numeric system, instead of just 2 characters, in binary we have only 2 characters, 0s and 1s. In decimal we have only 10, 0 up until 9. In hexadecimal numbers we have 16 characters, starting from 0, going to 9, and then from A to F. And each one of these characters represents a different number. So 0 means 0, 1, 1, and then 9, 9. And when we get to 10, instead of using 10, we use A, because it's only one character, right? 10 is 2. So we use A. And just a note, it's lowercase and uppercase, it doesn't matter. It could be lowercase a or uppercase a. And then B is equal to 11, and then F, the final character, which is 15. So that's hexadecimal numbers. Now let's take another number and calculate it. FA3C. Just like before, we take each character and we multiply it by 16 to the power of something. So we take the first character, which is C. Now C is 12, and then similarly to 3 times 16 to the power of 1, and then A, letter character A is 10. So for A, we take 10 times 16 to the power of 2. And then for F, as you probably guessed, it's 15. So 15 times 16 to the power of 3, which is this. And then we add them all together. So the result is 64,000 something. So this hexadecimal number, FA3C, is equal to this number. Now you might be saying, why on earth we need to use something like hexadecimal numbers when we have decimal numbers and binary numbers? Let's take this hexadecimal number. Now how many characters we use to express this number? Only 6 characters, right? 6 Fs. Now this number, if you do all those calculations, is this number. Now how many characters we use here? It's 8 characters. And if you want to see its binary number, well, it's a little bit more crazy. It's 24 characters. So that's why we use hexadecimal numbers. Its sole purpose is to help us as software engineers to work better with binary numbers. For example, if you want to see this gigantic number, it's really not too practical. It's way easier to see this instead of this. So it's just a system to help us as programmers to be able to deal with binary code, to deal with hardware, let's say, in a better way, in a better, more efficient way. So we just learned about 2 different numeric systems. And you've probably used hexadecimal numbers. Let's take a look at some examples. For example, in HTML and CSS, You usually tend to express colors in a format of a hexadecimal number, such as FFFFF or 0000000. Those color codes are just hexadecimal numbers. So you could convert them to a binary and you could see the binary code of a specific color. And the indicator that we use in that case is a hashtag sign. Another common example is in URLs. Some of the characters that are not in ASCII character sets, don't worry if you don't know what that is. We're going to talk about that in just a minute when we get to talk about character sets and character encodings. But basically, pretty much any character that is not in American Standard language, like A to Z letters and their uppercases, numbers, and some punctuations. If a character is not in that character set, in that system, we express that character in a URL using a hexadecimal number, and the indicator is just a percentage sign. Another example is in HTML and XML. Some of the Unicode characters, again, if you don't know what is a Unicode, we're going to talk about it in just a minute when we get to talk about character sets. Those characters are expressed using ampersand, hashtag, and an X. So it's another example. Just a quick note, the most common prefix is 0x. It's really common to use that in Unix system-based and in some programming languages like C and C++. But the point is that hexadecimal numbers are pretty common in the computing world, and it's really crucial to know what they are and how to use them and what exactly they express. Okay, so I want to take a moment and show you a way to convert between a hexadecimal number, a binary number, and a decimal number. And then we're going to get to talk about character sets and character encodings. So if I go ahead and open up my calculator, this is the default calculator for my system. If you're on Windows, go ahead and open up your default calculator, or just follow along, it doesn't really matter. So if I go to View and I change it to Programmer, currently it's Basic, and I change it to Programmer, we'll see some interesting things here. So let's start from the top. Here I could specify if my number is a base 10 number, or a decimal number, or a base 16 number, or a hexadecimal number. We also have another common numeric system in the computing world, and that is base 8 numbers. It's pretty similar to binary numbers and hexadecimal numbers, but the difference is that we only use 8 characters to express different numbers. And you can see here that when I change it to a base 8 number, these characters will be disabled. So I only have 0 up until 7. It's also called octal numeric system, but we won't use them throughout this course. It's usually common in Linux systems, like, for example, if you used file permissions like rxxx and other things like that, those are usually expressed in octal numeric system. So it's good to know about them, but we won't be using them throughout this course. Only decimal numbers, hexadecimal numbers, and also a little bit of binary numbers. So let's start to convert some numbers back and forth. If I put in a number, let's say 100, right here, I could see its binary format. It's 0, 1, 1, 0, 0, 1, 0, 0. So this is the binary number of 100. Now if I change it to 16, or a hexadecimal number, notice here that we are seeing this 0 and X. This is just an indicator and nothing else. You can see that now we have 64. So 100 is equal to 64 in hexadecimal format. Now, if I say that I have, let's say, 100 oranges, it doesn't mean that I have now 64 oranges, okay? So if I say that I have 64 oranges, but I express the number in a hexadecimal number, it doesn't mean that I have 64 oranges. It means that I have 100 oranges. I hope that makes sense. And yeah, that's pretty much it. If you're on Windows, it should have a similar way to do this, but I don't have access to a Windows machine to show you how to do that, but it's roughly the same. Whenever you need to convert these numbers back and forth, simply use a programmer calculator. It's pretty easy to do that. Alright, now let's talk about character sets. What is a character set? It's a collection of letters and symbols that a writing system uses, and a representation of assigning different numbers to those characters. So we have a set of characters, and then we have some numbers. Each character has a number. That's all. That's a character set. Now we have some common character sets out there. One of the most common one is Unicode. It's a standard for representing and encoding characters in most of the writing systems worldwide. So pretty much any characters that you could imagine, well, Unicode has it, and it has a number assigned to that character. No matter if it's Chinese, Korean, Greek, anything, a Unicode has a number for each character. And it defines more than 140,000 characters, which is a lot. And one example is that character S gets assigned number 115. So character lowercase s has 115 in Unicode character set. Another common character set is ASCII. It stands for American Standard Code for Information Interchange, and it only defines 128 characters. Lowercase and uppercase of letters A to Z, numbers from 0 to 9, some punctuations and symbols like $, parentheses, tilde, ampersand, and so on. And also some control characters like delete, backspace, control, and a couple more. And well, it's just a subset of Unicode, and because of that, its characters have the same number as Unicode. Again, for example, character lowercase s gets assigned number 115. So that's what a character set is. A collection of characters that each character has a unique number. And we also have some other character sets. Some of them are, for example, for different languages like Chinese, but these two are the most common ones in programming. Okay, now that you understand character sets, let's start to talk about character encodings. So a character encoding is a system of assigning a sequence of bytes, remember, just some zeros and ones, to a character. The most common one is UTF-8. It is defined by the Unicode standard, and because of that, its characters have the same numbers as the Unicode. So let's say that I have some characters on the screen. Let's make an example. Let's say that I have this string word, and let's now try to break it down using a character encoding using UTF-8 and see the binary numbers that these different characters would get assigned to. So letter S has the number 115, if you remember from the previous slide. It's defined by Unicode that the lowercase s gets the number 115. And if you do the calculations, this 115 has this binary code, binary number, 0, 111, 00, and then 111. And to prove it to you, I could go ahead and open up my calculator, and if I put in the number 115, and right here, if I choose the character set as Unicode, you could see the letter lowercase s right here. So 115 is the number for the lowercase s. And if I change it to ASCII, because it's just a subset of Unicode, it still has the same letter. So that's it. And also its binary number, you could see it right here, that same number that we just saw, 0, 111, and then the rest. Likewise, we have other numbers and binary numbers for the rest of the characters. So that's the purpose of a character encoding. It assigns different sequence of bytes to different characters. And that's why it's so important to define your character encoding for the application that you're using. For example, for a text editor, you have to define the character encoding. Otherwise, it would show wrong characters for a different sequence of bytes. Now, let's see an example. Now, let's say that we have this data. And using UTF-8, this binary number, this sequence of bytes, well, actually in this case, it's only 1 byte. We have 8 boxes, so 8 bits, and 8 bits is equal to 1 byte. If we give this data to UTF-8, it'll show the character t, lowercase t. So if UTF-8 character encoding gets this binary number, it will show lowercase t. Now, if we take the same data and we define our own character encoding, let's call it X. It's actually pretty easy to create a character encoding. Well, if we were to just define some characters, in that case, let's say that we define this byte to show the character 5. So using UTF-8, this data would show this letter. And using our own character encoding, This data, the same data, would show another character. That's why we always have to specify the encoding system. Otherwise, we might get wrong characters on the screen. So remember that. Always specify the character encoding. But the most common one is actually UTF-8, and in a lot of cases the default is UTF-8, so you probably don't need to specify it every single time, and if you don't do it, it would get defaulted back to UTF-8. Alright, now that we've understood character sets, character encodings, hexadecimal numbers, and binary numbers, and you also know that 8 bits is equal to 1 byte, well, that's pretty easy, but having said all that, we're now ready to start to talk about buffers. Alright, let's see what exactly is a buffer, and then we'll get into some coding. A buffer is a container in memory that has a fixed length size. In this case, it's a 2-byte buffer that gets in some data, some raw binary data, some zeros and ones, and then it quickly sends it on to another place. So that's basically a buffer. It gets in some data, and then it sends it out, just like that. And along the way, we would do some processing on it. We would get the data in the buffer, and then we would pull it out and do some processing on it. That's the idea of a buffer. Now, you might be saying, hey, why on earth we have something called buffers in Node.js? And the reason is JavaScript itself isn't good at all in dealing with raw binary data. And Node.js, because it's a web server technology, it needs to have a way to be able to deal with files and to deal with network requests. And as you already know, files and everything is just binary, it's just zeros and ones. And in order for Node.js to be able to deal with files, it needs to have a good way to deal with raw binary data. That's why buffers were introduced in Node.js. Because JavaScript didn't have a good way to deal with raw binary data, and it needed to solve that problem in order to be a good technology for a web server. Alright, now let's get into coding and see some examples. So I'm going to open up my terminal, and on my desktop I'm going to create a new file called app.js, and I'm going to open it up in my code editor, Visual Studio Code. And right here, I'm going to create a new buffer. So I'm going to write const buff equals buffer.alloc8. So this is the buffer class, and because buffer is so crucial to the Node core, it's available to us globally. So at any point in time, we could just write buffer and we get access to it. Now, Node.js websites recommends that we first include it like this, equals require buffer, but since it's just a small application, I'm going to omit this line and use it globally. So this is how we create a buffer, right? Buffer.alloc, and alloc means how many bytes we want to give to this container. Because remember, the buffer is just a container that we use to temporarily hold a fixed length sequence of bytes. And this 8 is its length, and it's specified in bytes. So now this container in memory has 8 bytes of storage. And if I go ahead and log this, I'll say console.log buff. And now I'm going to open up my terminal and run node app.js. I'll get a buffer. Now, each one of these integers are expressed in a hexadecimal number. And each one of them is 1 byte. So this buffer is 8 bytes. So we get 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. And now that we have our buffer, we could write data on it. We could write zeros and ones to it. And the way we can do that is to call the write method on it. So buffer.write, and let's just write the character s on it. And remember, we could only write binary data on it, and this is a string, so we have to use encoding to convert it to a sequence of bytes. And the character encoding I'm going to use here is UTF-8. And also the default one is UTF-8. So if I don't specify it, it's going to get defaulted to that UTF-8. Now let's log our buffer one more time. And now, as you can see, the first byte is now occupied. Because UTF-8, this 8 means 8 bits, or 1 byte. It means that each character is expressed using only 1 byte. So if I put another character here, like T, and I log this one more time, this time around, I get 2 of those bytes occupied. And here's something interesting. If I open up my calculator and I type this number, remember it's a hexadecimal number and it's 73. So I'll write 73. I'll choose it first to a hexadecimal number and 73. And if I change it to 10, you'll see the number 115. And that's the exact same character that we saw in the previous slides. And if I also change it to 74, now this is now the lowercase t. So basically what we're doing with this write is to say that, hey, take this string, encode it using UTF-8, get the bytes, and then write them to our buffer. Now, if we want to see the numbers, we could do so by calling the JSON to JSON method on our buffer. So using this method, we would get our buffer, but in a JSON format. So I'm going to go ahead and run my code one more time. And here, as you can see, it's an object, type is buffer, and then our data, those same numbers that we saw in that slide. In fact, if I change it to string, and I'll run it, you could see those exact same numbers. Now, the last 2 bytes are free, and it's because the string is only 6 characters and we have 8 bytes, meaning that we could store 2 more bytes on it. So if I write 1, 2, 3, 4, 5, 6, 7, 8, so 8 characters, and therefore each character would have 1 byte. If I run this, now as you can see, all the bytes are now occupied. Now what if I put something else here, like, for example, 9, 10, 11. Well, nothing happened. And the reason is a buffer has a fixed length size. So if you try to write more than its length, it's going to ignore them. It's not going to return an error, but it's going to ignore them. So these 2 are identical, even though in this case I wrote a couple more characters. And because it doesn't have the capacity to store them, it will just ignore them. So I want to say the definition of buffer one more time. It is a place that is being used to temporarily hold a fixed length sequence of bytes. So that's a buffer. And a buffer acts kind of like an array of integers. However, they are not resizable and have many methods available to them, especially to deal with binary data. For example, I could write buffer.length and log it. In this case, I'll get 8. Or I could access the first element like this, and I'll get 49. And 49 is the first byte. So it acts somewhat like an array, but the difference is we can't resize it, and we have a whole lot of methods available to it to specifically deal with binary data. And again, the reason that we have buffers in Node.js is because JavaScript itself, well, it's really good at dealing with Unicode encoded strings, but it doesn't really handle raw binary data really well. That's why we have buffers. In fact, let me tell you what I mean by Unicode encoded strings. We have a couple of methods available on the string object from car code and from code points. Actually, let me show it to you in the browser because it has nothing to do with Node.js and it's pure JavaScript. So I'm going to open up my Google Chrome and I'm going to open up my console. And I'm going to write string.from car code. And if I put in that character S, oops, actually we should do this. It's the other way around. So, excuse me, we give it the character code and it will give us the character. So it basically decodes that number. So it's good at dealing with Unicode encoded strings. We also have from code point. And to find the code point of this string, I have to open up my calculator and run 115 and change it to hexadecimal, so it's 73. So if I put 73, I'll get that S. So it's string.fromCarCode and string.fromCodePoint. So JavaScript is good at dealing with Unicode encoded strings, but it's not really good with raw binary data. Well, actually, ES6 introduced an idea called typed arrays. It is kind of like buffers, and it's really good at dealing with binary numbers, raw binary data. But at the time that Node.js was introduced, we didn't have anything called typed arrays in JavaScript, so Node.js had to come up with a new idea to deal with raw binary data, so therefore it introduced buffers. So we also have that typed array, but I'm not going to talk about that in this course. If you want, search about it. It's like buffers, but it's available to us in pure JavaScript in ES6. All right. Now let's have some more fun with buffers, and let me show you some more methods we have available on them. Well, one of the things that we could do, instead of this allocating some bytes and then writing on it, we could directly do this. So const buff2 equals buffer.from string, and then specify the encoding UTF-8. Let me comment these lines out. Now this means take the string and automatically find out how many bytes it needs to store the string in bytes using this encoding, and then write that on that buffer, just like this. And if I go ahead and log this, so console.log buff2, now in this case we don't have any empty bytes because it has automatically found out how many bytes it needs, so it allocates those and then write on those bytes. And if I run to .to.json, I should get these hexadecimal numbers now in decimal numbers, like that. Now, another thing that we can do is to do it in the other way around, meaning to write the exact sequence of bytes on the buffer instead of doing encoding and things like that. So buff3 equals buffer.from, and here I'm going to specify an array of those numbers, so 115. And if I now go ahead and log this, so console.log buff2, well, I get that same number, but the interesting thing is now if I try to decode it, so I say .toString and decode it using UTF-8. Now I should get the character S, like that, because 115 is character S. And I could go ahead and copy paste this entire array right here. And also the encoding here is hex, so if I now log it, I'll get string. Pretty cool, huh? So I could write these numbers. Well, actually, these numbers are just different binary numbers. And just a quick point, these values could be from 0 up to 255. And the reason that it's 255 is that each one of these correspond to 1 byte. And if I come here and open up my calculator one more time, and I change all of these to ones, the first byte, I'll get 255. So if I occupy the first byte, the maximum value, 1 byte or 8 bits, can hold is 255. So I can't specify, like, for example, 300. It's not going to work. But I could say 255. Just like that. Now, if I, for example, change this encoding to something else, like UTF-16, now Node.js called it UTF-16LE. If I now log this one, let's see what we'll get. Well, I'll get completely different sets of characters. Well, I don't know what language this is, but the point is, if you don't specify the encoding correctly, you would get completely different characters. Because in this case, this 115 is, well, those bytes is this 1, 0, 111, and then 00, and then 11. And UTF-8, this byte means the character S. In another encoding like UTF-16, this would mean completely something else. So that's why we always have to specify the encoding. Now let's do something else. Now let me show you an example of where buffers is used in Node.js. Well, there are actually countless examples, but in this case I want to just show you one. Now if I open up my Google Chrome and I type in a URL, let's search for example, a string. And I want to put in, and remember that I said that URLs are an ASCII character set. So if I specify a character that is not in American Standard Language or some of those punctuations and control keys, it will encode them and show a hexadecimal number instead. Now let's go ahead and pick up a character. So I'm going to open up Google Translator. And let's do it from English to, let's choose, for example, Chinese. And I want to say hello. And I want to copy the first character. And right here, I'm going to search for that character and then just string. Now if I copy my URL, and if I head back over to my Visual Studio Code and I create a new file, I'll paste that URL in. So as you can see here, our query is now a hexadecimal number and then that string. So that Chinese character that we just saw got converted to this hexadecimal number. And if I go ahead and put it right here, so I say const buff3 equals buffer.from. Now I want to put in the hex format. So it's E4 BD and then A0. And now I want to log this in. So console.log buff3 .toString UTF-8. Well, this is the exact same character that we just saw, right? This one is this character. Let's make sure that they are identical. So yes, they are. So this is one of the examples that Node.js is using buffers, well in this case to encode and decode URLs. All right. So now we should have a pretty good understanding of buffers and how to use them and why do we even have them in the first place. And I encourage you to go ahead and read the buffers documentation in the Node.js website, and with the knowledge that you have right now, you should completely understand all of it. In fact, let's go ahead and take a look at it together. So I want to open up my Google Chrome and search for Node.js buffers. And we have two pages in the Node.js.org website. One is just a quick introduction to it, and then another one is its full documentation with all of the methods we have available on it. So let's open both of them and let's start to read them. So how to use buffers in Node.js. It's a pretty small article, but you should completely now understand everything that's going on here. It says that JavaScript, while great with Unicode encoded strings, we just saw in this video what this means, does not handle straight binary data very well. And we know that it's true. And this is fine on the browser where most data is in the form of strings, but Node.js servers have to deal with network requests, files, and so on. And for all of them, we need to have a way to be able to deal with pure binary streams of data. And one way to handle this problem is just to use strings, but this is not a good practice. It tends to break in strange and mysterious ways, and, well, it's slow and it has some problems to it. So that's why we have buffers. Now, the definition of buffers is here. The buffer class in Node.js is designed to handle raw binary data. Each buffer corresponds to some raw memory allocated outside V8. And buffers act somewhat like arrays of integers. We saw this in this video, but aren't resizable and have a whole bunch of methods available to them to deal with binary data. We also saw this part. And the integers in a buffer, each represents a byte, and so are limited to values from 0 up to 255. We also saw this using our calculator. And when we log a buffer, it prints the buffer instance, and we get a chain of values in hexadecimal values. So this should now make great sense to you. Well, the only thing that we didn't quite talk about is this V8. There is another video in this course before this video, and in that video we talk greatly about V8 and what is it. So if you go ahead and watch that, you will also understand this sentence here. Okay, and then some code, how to create buffers, and some methods that we have, all of which we saw. So you should now understand all of it, but come here and read it and play around with it a little bit. All right, now let's take a look at its full documentation. You could first go to the Node.js.org website and then click on the documentation, and right here on the left sidebar, click on buffer. Now here we can see all the methods that we have available on it. Well, of course it would be too unpractical for me to show you all of them in this video, but now that you understand hexadecimal numbers, you understand binary data and binary numbers, and the concept behind buffers, you also understand character sets and character encodings, you should now come here and feel pretty comfortable reading this whole documentation and completely understand everything that it says. So here we are seeing some of the character encodings we have available on it. We saw hex, UTF-8 and UTF-16. We have a couple more. Here's the list. And we also have a way to use buffers with typed arrays. Remember, typed arrays were introduced in JavaScript in ES6. We didn't used to have them, but now we do. And there's also some ways to use them together. And since buffers are just like arrays, we could iterate through them and log them, just like an array. Now we have a couple more methods and properties available on a buffer, but if you see their definition, you should now understand what is really going on. Alloc, fill, they might sound pretty intimidating at first, but they're actually pretty easy to understand. Just give it some time, read the definition, and then try to write the code down, run it, and play around with it a little bit. In that case, you could really understand a lot more about buffers. We also have another method called buff.equals, and it returns true if both buffers have exactly the same bytes. Just like here. We also have buff.indexOf, buff.keys, all of which, again, are incredibly easy to understand. We have a couple more. So I suggest that you come here and read this whole documentation and run some of these codes and just play around, see different methods and try to understand some of the capabilities that buffers offer. Now, in the real world, you rarely need to use buffers directly. In most cases, it's given to you, and it's mostly used by other Node.js utilities and APIs, but it's really good to know about them and also understand the concept behind them. Now, if we recall, we said that data usually comes in from one place, and then it goes to another place. Now, these places that we talked about are usually streams. And it's coming up next in this course. We have a video dedicated completely to talk about streams, because streams are also a crucial concept in Node.js, and we will dive deep into it and really understand what is going on behind the scenes. So that wraps it up about buffers, which is essential to understand in order to understand other core Node.js concepts. If you don't know buffers, then you will not properly understand streams. And if you don't know streams, you wouldn't know the file system. And if you don't know that, chances are that you wouldn't know the HTTP module, and so on. A lot of concepts of Node.js are dependent on each other, just like many other things. And as someone who uses Node.js to create applications, it's vital to understand them deeply, and not just to be someone who knows how to use packages like Express, Malter, Nest, and so on, to be someone who is capable of creating something like Express himself. And not only that, but also to be able to pick up a package and read its source code and understand fully what's going on. That requires us to understand these core concepts, and we're going to dive deep into all of them throughout this course. Okay, let's keep going.